My name is Doug Resnick. I'm a Vice President for Molecular Imprints, and my focus is on strategic development. Initially, that meant developing technologies and securing infrastructure for the semiconductor division. More recently, it's been to establish jet and flash imprint lithography, which is the technology we use to print for emerging markets such as displays, hard disk drives, the energy sector, perhaps nanobiotechnology as well. Canon has acquired the semiconductor business of Molecular Imprints. Now, that means a couple of different things, and I want to discuss both. How it relates to our semiconductor business, but because Molecular Imprints is also focused on emerging markets, the business and the acquisition of Molecular Imprints semiconductor business also has ramifications on the emerging market side too. So let's discuss semiconductor first. Canon has what they call an excellent global corporate plan. And the idea is for them to expand further their global diversification. And the way they wanted to do that was to establish regional headquarters outside of Japan, okay? And the United States, of course, qualifies. And by acquiring Molecular Imprints, that satisfies part of their plan. What's much more interesting, however, to Canon is the fact that by acquiring Molecular Imprints semiconductor business, this gives them the opportunity to participate again in the high-end lithography business. They've been out of that business for a little while. We give them the opportunity to move that back into that business. Okay, so that's the primary focus for Canon wanting to acquire the semiconductor part of the business. So it works for them, it also works for us. We're very good at imprint technology. It's been developed at Molecular Imprints since 2001. We bring expertise in that area. Canon lends its manufacturing capabilities and also its service organization. And now this gives us a very solid presence in the semiconductor industry, particularly for applications such as semiconductor memory, NAND flash in particular. Okay, so that's the first part of it. As a result of the acquisition, what happens is part of the funds now go over to a spin-out, which will still be called Molecular Imprints. So what's happening is about 3/4 of the folks will become Canon folks. The remaining 25% will be part of the new Molecular Imprints. And there they will focus on emerging markets. In other words, things that don't include semiconductor. And this will range anything from displays to the hard drive industry, to the energy sector, and to biotechnology applications. So it gives them solid funding to develop tools and processes and break into that business. The lithography business for semiconductors is huge, right? And all the big money to be made is in high-end lithography. And right now that means technologies that can take you beyond half pitches of 20 nanometers. Okay, so that's the space that's very important. And I think Canon saw this as an opportunity to get back in the market. The technology was a good fit. Basically what we do for Canon is, because we're imprint lithography experts, we supply an imprint module and do the research development and the technology development to go ahead and implement high-end solutions and make it viable for folks like NAND flash manufacturers. Jet and flash imprint lithography has been the technology that's developed since the early days when it was done solely at the University of Texas by Grant Wilson and S.V. Srinivasan. The beauty of the technology is basically what you're doing is you're putting down a low viscosity resist on a substrate. You're bringing a mask or a template in contact with that liquid resist. The resist fills in the relief images on the template. You then photo cure it, and you have an image. Now, the beauty of doing that is relative to most of the other technologies you find discussed at SPIE, which are all related to optics. There's no aerial image associated with our technology, right? When you shine light through a mask, you don't have a square wave that's projected on that resist. There's a certain aerial image, and it is not perfect. For imprint lithography, the shape of the template defines the actual resist feature. So if you can put the feature on the template, you can print it. And people have shown the ability to print features as small as 2 nanometers. Okay, so there's a lot of legs to the technology. What that means for the semiconductor businesses, since they need to go down to 20 nanometers and below, you provide a single printing solution. You don't have to do spacer double patterning or DSA tricks. So that makes it a very inexpensive, very cost-effective process. For the emerging markets, they need features below 50 nanometers, depending on the application. For example, a wire grid polarizer, how well it transmits, what the contrast of that polarizer is a function of many things, but one is the pitch of the device. And if you can make a 100 nanometer pitch or a 50 nanometer half pitch wire grid polarizer, you get outstanding performance, both from transmission and contrast. Right now, for devices such as displays, we're very comfortable addressing devices with dimensions up to tablet size. So for mobile applications, it's already a solved problem, and there are several different ways you can scale that up. Right now, we've scaled a tool to be able to print on what's called a Generation 2 plate, a Gen 2 plate for the display industry. That's bigger than a silicon wafer. It's 370 millimeter by 470 millimeter on a side. So we're starting to get to very large areas, and our engineers are very good at scaling. So there's no reason why that can't eventually address sizes such as Gen 5, Gen 8, and even possibly Gen 10. There you're starting to talk about dimensions which are greater than 3 meters on a side. So that's very, very big engineering, but that's down the road.